Welcome back to the second part. Enjoy the video. So we've got two examples doing this one. These are worked though. You can pause it now and give it a go. I'll assume that you've done so. So I'll make the link seamless. Oh, welcome back. So firstly, I've just rewritten the question, and we're going to substitute in. If we look at it, it's all in terms of cos and sine. How are we going to solve for that? Yeah, so we need to eliminate, or we need to express cos in terms of sine. So as I've just said, cos squared is 1 minus sine squared. So I'm going to make that substitution there. And what's the next thing we should do? Egal it, expand. Yeah. Should say expand here somewhere, maybe not. So we expand that, and then we group terms and we set equal to 0. Yeah. So at that point we have the choice of factorizing or solving. Yeah. At this point, I don't care if you factorize. I don't care if you use the formula, quadratic formula. Use a quadratic formula. Realize A is 5, B is minus 9, C is minus 2, and we've not found x. We found sine x. Yes, we still got a little bit of work. So once we found sine x, yeah, we can do sine inverse of those answers and we get minus 11.5 degrees. Yeah, so there's two problems there. We've got two solutions. The first one yields a solution. What happens when we do sine inverse of 2? Gives you maths error. Why is that? Because the ratio at the back. Yeah, that's it. Exactly. The ratio of the opposite to hypotenuse has to be less than or equal to 1. Is 2 less than 1? No, it's not. Yeah, so we have to ignore that solution. Yeah, so we discard that one and we just deal with the negative 0.2, and that gives us negative 11.5 degrees. So this is our primitive solution, but it's not in the range. But we need it. We need it to figure out the ones that are in the range. So if you're not sure about the next bit, look at my periodicity video. It should be easy to find on YouTube or easy to find on my website, rathsmaths.com. I like flexing. I've got a website because I made it myself. So yeah, so we've got that. So we have the minus 11.5. If I draw the sine curve, you should be familiar with this. We can see there that this is negative 11.5. So we're just drawing a horizontal line through that point, and we look for the values that are equivalent. Yeah, so the same height, distance from the x-axis. And we have 11.5 degrees to the right of what would have been 180 here. Yeah. You can see that's 180, and then this is 360, and then we've got 11.5 to the left of it. So that gives us the solutions that are in yellow. I think I've been quite clear there. If you're not sure of this, yeah, again, just watch the periodicity video. Jot that down, and let's do number 2. So again, pause the video, attempt this, and then unpause it when you're finished. Just going to have a little drink. All right. Hello again. So firstly, just look at this. Bit of a mess in terms of cosec and cot. Yeah, but we know that from the other identities we've seen earlier, well, also at the top of the screen I've put, we can see that we can write cosec squared in terms of cot. Yeah, we just need to rearrange it. So we can see that cosec squared is 1 plus cot squared. So we sub that in and then expand. Expanding, we get 4 plus 4 cot squared minus 9 equals cot x. So you've got something that's a quadratic. How do we solve a quadratic? That's right. We'll set equal to 0. Now, earlier in question, example 1, I said you could solve this with a formula, what have you. Yeah? So we'd have A is 4, B is -1, C is -9. I'm going to do this one like what I describe as a disguised quadratics. Again, I'm no Englandmatician, so I don't know what that topic's called, but it's a quadratic which is in a different form. One might say a disguise, hence disguised quadratic. Yeah. So I'm making a substitution of y equals cot x essentially. Yeah. So therefore y squared would be cot squared x. So if I look at that, I factorized it and I've got those solutions. Again, if you use the formula, you'll still get y is 1.25 and -1. Or obviously, therefore cot x equals 1.25 and cot x equals -1. So that means if cot x is 1.25, tan x, which we do have access to on the calculator, because we don't have access to cot, so we have to put it back into the regular trig functions, is the reciprocal of 1.25. So I know 1.25 is 5/4. What's the reciprocal of 5/4? 4/5, yeah, which is 0.8. If you don't know that, just do 1 divided by 1.25 and you get 0.8. Yeah, so we can put it in terms of tan, and then we do tan inverse, and what we will get is those primitive solutions of 39 degrees and -45. Yeah, so again, like in the previous example, one of those solutions isn't in the range. Yeah, so now we have to look at the periodicity of it. And what I mean by that is how often the tan curve repeats. So if we look at the tan curve, hopefully you can see it just repeats every 180 degrees. Yeah, so I'm going to use, hopefully I should have some sort of useful graphic here somewhere. No, I don't. Pretty sure I did though. All right, so anyway. So tan repeats every 180 degrees. So you just add 180 degrees onto your answer. Yeah, and we get that. Now, the problem why I avoid doing what I'm about to do now normally, but I'm tired, so I feel like in a funny mood, I will do it anyway, is this comes up on the screen super fast for me, and I think how you see it is terribly slow. But anyway, I've got this line, and that could represent, let's say I'm looking for 39 degrees. That would be, say that's somewhere there, yeah? So if that's 45, let's fair to say that's 39. We can see we've got one solution there, another solution there, and another solution there, where they're all equivalent. That third one is outside the range. So this would indicate the the 39 plus 180. Yeah, so 219 degrees. If I look at the -45, that is going to be around here somewhere, yeah? So that will give us, if we add on there, that reflects 135 degrees there. So when we do the graphs, that's essentially what we're looking at periodicity. Yeah? I'm not going to labour the point because, again, I've got a periodicity video that you can find on my YouTube channel or at razmaths.com. So, yeah. That's all I have to say about that. So go to the video, should link on YouTube. If not, look for that one, and it will be examples only. A banter-free zone ish. See you on the other side.